Hi all, welcome to E-Content Development Center, Majalis Arts and Science College Autonomous, Puramannur. Myself Ranjin K, Assistant Professor, PG Department of Mathematics. Today we are going to discuss few topics from abstract algebra. First one is group and second one is subgroup. We are also discussing few topics, examples of groups and subgroups. After discussing these topics, you will be able to understand what is the basic concept of groups and its properties, as well as you will be distinguished between various types of groups such as finite and infinite groups and abelian groups and non-abelian groups. Also, we will be able to identify which are groups and which are not. Now let's get into the definition of a group. Before defining a group, we need a non-empty set G along with the binary operation star. So the G along with the binary operation star is said to be a group if it satisfies the following conditions. Let's check the conditions first. First one is closure property. What do you mean by closure property? For any two elements A, B belongs to G. It is a random element A and B. Then the G must have A star B as well. Okay. Then the G is said to be closed or it satisfies closure property. Next one is associativity. For associativity, we need three elements A, B and C. And if A star B star C equal to A star B star C, then it is called the G satisfies associative property. The third one is existence of identity element. There exists an identity element E in G. That is, E star A will be A itself, the same as for A star E as well. Then the element is called an identity element. Okay. Then the last one is existence of inverse. For G to be a group, every element of G should have an inverse element. So for every A belongs to G, there exists an A inverse in G such that A star A inverse will be the identity element E. Same for A inverse star A as well. If it satisfies all the four conditions, then the G along with the star is called a group. Now we are going to define abelian group. What is abelian group? A group G star is said to be an abelian group if it satisfies all the conditions of a group. That is, we just discussed before. And additionally, it should satisfy another conditions. What is that condition? It is commutativity. And what is commutativity? For any two elements from G, then A star B must be equal to B star A. Also note that a group can be either finite or infinite. Sometimes we call a group is finite, sometimes we call it as infinite group. What is the condition? Depending on the number of elements in that set. If the set has infinite elements, then it is called infinite group. Otherwise, it is called finite group. Now, let's get into some examples of group. First, I am considering the set of all integers set along with the binary operation addition, that is usual addition. Now, I am checking the first property of group. We know that the sum of any two integer is also an integer. Therefore, the first property, closure property, is satisfied. Otherwise, we can say that set plus is closed. Then the second one, associative property. For associative property, I am choosing 3 points A, B, C from set of all integers. That is, A, B, C are integers. Now, by doing this A plus B plus C, we are getting the same A plus B plus C. So we can say that G satisfies the associative property. Next one is existence of identity. We are checking whether there is an identity element or not. We know that the element 0 is an integer and 0 plus any element, that is, for example, A belongs to set, 0 plus A is getting A itself, the same for 0 plus A as well. So we can consider 0 as the identity element of set of all integers. So set satisfying the property, the third property as well. The next one is existence of inverse. We are checking set has inverse for each element. For that we are considering an element A belongs to set. We know that if A is in set, minus A will also in set. For example, if 1 is an integer, minus 1 is also an integer. If 2 is an integer, then minus 2 is also an integer. So minus A should be in set. Now we are checking A plus minus A. By doing that we will getting 0. 0 is the identity element of set. So we are getting the identity element. Same for minus A plus A as well. Thus we can say that every integer have an additive inverse. Thus we have checked all the conditions of a group and all are satisfied. Thus we can say that set plus is a group, or set is a group along with the binary operation addition. We know that addition of numbers is commutative. So for any A B belongs to set, A plus B will be equal to B plus A. So we can also say that set along with the binary operation addition is also an abelian group. So we can say that set plus is an example for abelian group as well. Now let us consider another example. I am considering the set of all natural numbers n along with the binary operation minus, that is usual subtraction. Clearly n along with the binary operation minus is not a group. Why? Because for any element A and B from set of all natural numbers, A minus B will not be an element of n. What is the reason? For example, I am considering the element 2, which is a natural number, and 5, which is also a natural number, and I am doing the operation, that is 2 minus 5. What I am getting? I am getting minus 3, which does not belongs to n. It is not a natural number. We all know that. Therefore, we can say that n is not satisfying closure property. Therefore, n along with the binary operation minus is not a group. So we have discussed the few topics from abstract algebra, groups, subgroups, and 2 of the examples of groups as well. Thank you.